Hello and welcome back to Episode 3 of Kerbal Space Programming, the series where I try to learn how to code in Python by connecting it to KSP and launching rockets with it, ideally without killing the occupants of those rockets. And that, I have to be honest, is where I've been struggling a little bit so far. All told, 5 brave Kerbals have lost their lives now in the line of duty, often for no meaningful results whatsoever, or because of very, very trivial mistakes on my part. So the objective remains the same. It's to launch a Kerbal up into space and safely return them back to the surface. Will we finally see some progress on that objective in today's episode? Let's find out. I'm going to have a look at the astronaut complex here and just remind ourselves of the friends that we've lost along the way. Jeb, of course, poor Jeb, died very early doors due to an unfortunate mishap with a parachute not opening. Bill, the same fate. Bob, also the same fate. Valentina, again, the same thing. And then finally, Lodza. Lodza, we had some success with the last time. We actually managed to launch Lodza, and the parachute successfully deployed, and he returned to the surface after a very short vertical flight. And then we changed a parameter, and for some reason the parachute did not open the second time, and so Lodza is gone too. So we're pinning all our hopes at the minute on brave Frola Kerman. We've taken a big hit to our funds. So as a reminder, we're playing in career mode on this playthrough. That means you've got to manage your money. It means you've got to manage your science. And you've got to manage your Kerbals, and they don't come for free. The next higher, you can see 79,000 Kerbal bucks, and we've got 43,000 Kerbal bucks. So yeah, Frola's the man, and we're going to have some success today. I can feel it in my bones. As a reminder then, the way I'm running this playthrough, I'm not touching the manual controls at all, apart from when Kerbals do an EVA. Everything else will be controlled through Python. This is my VS Code setup, and this is the code that we ended up with last time, imaginatively called firstlaunch.py. We've had several launches with it now, and they have all been unsuccessful. My hope today is that finally we can nail down this issue with parachutes not opening, staging not working properly, because ultimately that's what's resulted in the deaths that we've experienced so far. And I'd really like to stop killing Kerbals. I really, really would. So today, we're finally going to get to the bottom of what's going on, and we're going to fix it. And we are going to fire some rockets, and they're going to stage correctly, and everyone's going to be happy, and it's just going to be a wonderful experience. And Frola, most importantly, Frola Kerban, is going to survive. I'm employing, I think this is called manifesting, right, where you just say stuff that you want to happen, and then it happens. We'll see if it works. So, I've been doing a little bit of research in the intervening weeks since the last session, and I've worked out where I might possibly lean on some aid or find some way of helping myself. One of the functions that I've found is a function that allows you to print your vertical speed, which I figure would be useful. It would be useful to see what the vertical speed's doing. This is the bit that controls the parachute, the all-important parachute, the thing that allows the Kerbal to return to the Earth in one piece. And the way this works is, so while true, this is one thing that we encountered previously. I didn't have this while true statement here. So the code would run through it once, whilst on the launch pad, and then nothing would happen, which is why the parachute wasn't opening later, and ultimately resulted, I think, in the deaths of 3... I think we lost 3 Kerbals to that. So adding in while true essentially says, keep doing this, keep checking this, and the time sleep says do it every 0.1 seconds until this condition is true. If the ship's vertical speed is less than 0, so negative, that means descending, effectively, and the vessel flight surface altitude is less than 1,000 meters, then activate the next stage, which should be the parachute. Activate the parachute, and then break out of this loop. So that's the thinking. Now, what we were finding is that wasn't, strictly speaking, working. So what I thought was, okay, well, let's make absolutely certain that vertical speed is actually less than 0. Let's make sure it's negative, because maybe that's where we're going wrong. Maybe it's not registering vertical speed. And so what I've got is a command that allows you to print out, oh, not sure what happened there, to print out the vertical speed and print it relatively regularly. This is going to print out every 0.1 seconds until this breakpoint, ultimately, until we break out of this while loop. So we're saying print the altitude. This will print the word altitude and a comma. It will then print, this is the altitude value that it's pulling out of vessel.flight. And then it's going to print meters, a break, vertical speed, comma, and then the vertical speed variable with meters per second afterwards. What I'd really like to do is reduce the amount of propellant in this to the lowest I can get away with. It will burn for 0.9 seconds, and it will produce a delta V of 118 meters per second, so that should be low enough that we don't damage the parachute, which is the key thing. If we damage the parachute, then Frohler is toast. And the objective here is very simple. It's for this to print out the altitude and the vertical speed, to let us work out what's going on, to make sure that these two values are working as intended. If they are, if the vertical speed does show as below 0 and the altitude does show as under 1,000, then I'm going to be massively out of ideas, I think, at that point, and we're going to have to do some real homework to work out what the hell's going on. Man, I'm a bit nervous. I'm a bit nervous. But this should be okay. They're both in the same stage, so the parachute should fire instantly. The rocket will fire, but it will only take us up to 100 meters per second, which shouldn't damage the parachute. So Frohler should be okay, he said, full of confidence. Right, we're going to do this. So I'm going to keep it in this view with the code and the terminal showing, because my hope is that down here in the terminal we're going to see some data popping up. We should see the altitude and vertical speed line by line every 0.1 seconds showing up down there. Here we go, fingers crossed. Let's do it. 3, 2, 1, go. Yes. Yes. Please work. Please work. Right. Ah. Right. God, I'm really glad that worked, because as you can see down here in the terminal, I've made a simple spelling error. So if we'd sacrificed Frohler because I'd failed to write the word altitude properly, that would have been an issue. We're going to launch again, and we're going to see whether or not the correctly spelled word altitude now allows this function to print, and we start seeing some data back. So let's go again. 3, 2, 1, go. Ah! Now we see the problem. This is the issue, and has been the issue all along. And in fact, this explains why, when we launched Lodzer from memory, we had if vessel flight vertical speed is less than or equal to 0, then trigger the parachute. And you can see here vertical speed is showing as 0. So when Lodza was in the rocket and it was less than or equal to 0, then it was triggering the parachute because vertical speed was 0. And the change that we made was that we took out the less than or equal to. We just changed it to less than 0, which is why the parachute then didn't deploy, and ultimately that's what resulted in Lodza's unscheduled retirement. So we found the problem. This is the root cause. This is the issue. So this print function is now working properly. So that's great news. Now the question becomes, why is the vertical speed 0 when it clearly isn't? Right, I'm just going to have a look on the KRPC documentations. So the KRPC mod has some great documentation. It's mega useful. It's even the basic tutorials, frankly, are beyond me in terms of my Python ability, but it does give you some little pointers, or at least get you thinking about where things might not be quite right. And in fact, here we go. Here we go. There's a staging script here specifically around parachutes for a suborbital flight. And it's using vessel.flight, as I've got here, but in the brackets they're using vessel.orbit.body.reference frame. I think the reason that vertical speed is 0, it's giving you vertical speed from the reference frame of the ship. So the ship is looking at itself and saying, well, in this reference frame, nothing's changing, nothing's happening. My speed is 0. What actually you need is how is the vessel's vertical speed changing relative to something else? I'm gonna go down here. I'm just gonna type this vessel.flight, open brackets. Defaults to the vessel's surface reference frame. That's exactly what it's saying. So if you put nothing in there, then the reference frame of vessel.flight is the vessel itself, and the vessel doesn't see any movement relative to itself. Man, what a mind pickler. So yeah, this is the bit of code here. Vertical speed, vessel.flight, and then within these brackets, vessel.orbit.body.reference frame. So that's the only change I've made, is literally putting that code in there. All right, we're going to fly again, and again we're going to look at what happens with the vertical speed and see whether or not that changes. So here we go. 3, 2, 1, go. Parachute deployed successfully again. Fantastic news. Right. And you can see as the ship has started to descend, the vertical speed is now showing negative because we've set it up relative to the planet. Basically, it's the vertical speed relative to the center of the planet. Okay, man. And it's sort of stabilizing because the parachute's out, the parachute's stabilized the speed, altitude's coming down. This is going to be great for plotting some neat plots later on once I've actually... I mean, don't run before you can walk, right? Altitude 2 meters. Okay, and we're down to 0. Fine. Okay, so I'm going to exit this again. And I'm going to clear. This is printing the vertical speed. But if I look at this here, if vessel flight dot vertical speed is less than 0, that is still going to be, because I've got nothing in these brackets, this expression here is still going to be resolving as 0. So I need this code section here. I need to cut that out and I need to put it in here. Now these are equivalent. That vertical speed, which is the printed value, and this vertical speed, which is what the control is actually using to control the vessel, should be the same, which means this should go negative now when descending. And vessel flight dot surface altitude less than 1,000. Okay, we're going to try again, and what should happen now is that the rocket should launch, it should go up, the altitude should stay below 1,000 because I've not put enough solid fuel in there for it to go above 1,000, but the parachute should not deploy until the speed goes below 0, which is when we start descending. So if the rocket goes up and at the point at which it starts to descend the parachute opens, then we have success. I'm going to save this because I feel confident that actually, finally, we might have this. 3, 2, 1, go. Huh. It did not work. It did not work. Ah, but there was a click at the top there. I've still got them in the same staging pattern here. I need to separate the stages. I need to put the parachute in the second stage. But there was a click at the top there. As it went over the top and started coming back down, there was a click. A click that sounded an awful lot like it trying to deploy something. So that's encouraging. As we've learned previously, we count down in stages, so we start with stage 1 and then we go to stage 0. Third time's a charm. Here we go. 3, 2, 1, go. No parachute. Wait for the descent. Speed's coming down. Come on. Oh. Oh my goodness. Finally. Finally, the most basic, rudimentary, terribly written piece of code is actually doing what I wanted to do. Frola stands on the shoulders of the giants who've come before him. 5 brave, deceased, some might say needlessly deceased Kerbals, but Frola has made it. I'm going to revert to vehicle assembly because I want to do 2 things. The first thing I want to do is add a decoupler. So we spent a bit of science last time, and we bought ourselves some decouplers. So I'm going to add a decoupler in there. I'm going to put the booster back on. It's the only change I'm going to make, and I'm going to put the decoupler in the same stage as the parachute. So the decoupler and the parachute should both trigger at the same time, and they should trigger after descent begins, basically. And I'm going to put a bit more fuel in this as well. Where does that get us to in terms of delta V? I'm just going to put in... Right, I'm going to double the amount of fuel. It takes us up to 222 delta V, and we're going to see how the decoupler behaves. So I'm going to go back to launch. Right, so we're back on the launch pad. We've got Frola in his new, slightly beefier rocket with a bit more fuel to it. We've got a decoupler now. We're going to use the same script, and we're just going to slowly feel our way towards what we can kind of do next and what we can get away with. So 3, 2, 1, go. All right, we've gone up a bit higher. Will we break through 1,000? Yes, we do. Yes, we do. So it shouldn't trigger immediately when we go negative here on the speed. And it doesn't. Great. So we're now descending. We've got to break through 1,000. At 1,000 meters, it should open. Look at that. Oh. Don't worry about that. That's just a bit of... That's just a bit of an explosion. It's fine. It's just a bit of damage to the launch pad. Nothing wrong with that. We sort of touched on last time that what I really like is to unlock an unmanned probe just to help protect the Kerbals a bit more. So that is over... Where was it? We've got to go for basic science. Yes, that's it. Basic science. Unlocks the Probodobodyne Stayputnik, which is a zero crew kind of robotic variant of the capsule. So we can finally stop sacrificing Kerbals quite so readily. Although part of me thinks I should just, keep chucking Kerbals at it. But we need 45 science to unlock, and we've only got 7.3 at the moment. So we need to get some science from somewhere. I think a good way of doing this is going to be to launch rockets to some of the other sort of biomes around here. And this is the other little bit of homework that I've done. Relates to the bit of code that I was struggling to understand initially, which is this line up here, line 8, vessel autopilot target pitch equals 90. And if you remember, we previously had, I think it was target heading, equals, well, it wasn't equals, was it? I think it was target heading 90. I think that's right. Your pitch is, okay, what angle do you want the rocket to fire off at, and the heading is what direction do you want it to go in, based on the angle from north. So what that means is we can adjust the heading and we can adjust the pitch. What I could do is set the pitch, for example, to 45 degrees, which means that it would launch off at a 45-degree angle, and then I can use the heading to say, well, what way do we want to go? Do we want to go over here? Or do we want to go up here? Do we want to go this direction? So that's what we're going to do. We're going to adjust these parameters. We know, hopefully, that we've got a rocket that is going to survive. Although I've said that many times before, so who knows. And the other thing we're going to need to do is increase the amount of fuel, because we're not going to get very far if we keep doing tiny little hops. I'm going up to the maximum amount. Yeah, I'm going to go up to the maximum amount. Fuck it, let's see what happens. So, let's modify this code. I need to make sure... do you know what I've done here? And I'm glad I've caught this. Target pitch and heading. There we go. Not target heading. So pitch is first, heading is second. So I want the pitch to be 45 degrees. And for the heading... Man, great question. Where's north? Where's north? I mean, it shows north on my nav ball, but target pitch and neck. Right. So I mean, I'm just gonna give it a heading. I'm just gonna say 90. We're just gonna go in 90 and see what happens. So we'll shoot off a 45-degree angle and then 90 heading, and we'll see where we end up. And we're gonna give it all of the fuel. We're going to throw caution to the wind, because that's always worked in the past. We're going to give it a go. 3, 2, 1. Launch. Oh wow. Okay. Well, it's okay. So it has stabilized. It's gone to 90. We're over 1,000. Oh wow, he's tearing. He's absolutely tearing. Where are we going to here? Oh boy, quite a long way. Apoapsis, 10,500. and that's rising because the air pressure is dropping. I feel like this was a risk. I feel like this was a big risk. I feel like our re-entry speed is going to be high. Surface speed is rising? Okay, makes sense. Yep. Because we're coming down. 218. So this is still okay, I think. 228, 229. We're coming back down because the atmosphere is getting thicker. So the surface speed is actually falling. What about vertical speed? Can we get that? Vertical speed, minus 108. So we're coming down. We're coming down. This is looking okay. We're going to hit 1,000. The question is going to be, are we going to have enough time for the stage to happen and the parachute to deploy properly? Here we go. Oh, Jesus Christ, that was close. Man, that was close. I thought the booster was going to hit us on the way down there. Blimey, blimey. Here we go. We're going to time warp forward. And we're in the water. Look at that. Look at that. Beautiful. Ah, the rocket actually survived as well. So I'm going to get a crew report. Crew report. 2 science. Great. Well, we'll keep that. And like an EVA as well. EVA report. We'll take that. Get back inside. Aboard. There we go. Space Center. And recover. Recover and Death Trap 1 recover. There we go. 16 science, fantastic. Okay, so we can do that a bit more. So there's a bit of tweaking to do with our flight path. There's probably a bit of tweaking with the staging to do. But positive progress. We have a rocket that stages correctly. We have a rocket that is survivable. And we have the ability now to fly to some different biomes, collect some science, hopefully unlock the probe that will allow us to protect our precious Kerbals' lives. And we're going to get into, I think, some new stuff. Multiple stages, and ultimately bigger rockets getting up into space itself, out of the atmosphere fully. Start looking at some contracts, and ultimately I want to start pushing towards getting into orbit, into a stable orbit. All that's to come. Thank you for watching, and we'll pick this up next time. Thanks again for watching, and see you later.